Okay, in this video, we'll be continuing with the dynamics question. So this is in Grindale, page 66, question 4. Okay, so a block of mass 6 kg, so this is the M, right? It's pulled across a rough surface, that means there's going to be friction, right? The pulling force is 54 Newton. It is against a friction force of F. So of course, friction opposes motion, therefore it is in the opposite direction, all right? Then they tell us that the acceleration is 6 meters per second square. So whenever there's acceleration, we can find F net. Using this formula, F net equals to ma. So 6 times 6, the mass is 6. Make sure that the mass is SI unit, alright? That means your F net equals to ma is a SI unit formula. So equals to 36 Newton, okay? So that means the F net, I'm going to just redraw the free body diagram here. 54 Newton, unknown frictional force. Okay, so how do we draw F net? It is always drawn not touching the object with a double arrow. Not touching object with a double arrow. So due to the interaction of these two forces, my F net is going to be 36 Newton. Therefore, F net is equal to the larger force minus the smaller force. So 36 equals to 54 minus F. That means my F is going to be 18 Newtons. Okay, so B is the answer for this. So always draw your free body diagram. Okay, question 6, also Grindale. It shows the variation of net force with time acting on an object which is initially at rest. So initially the speed is 0. And actually this is my F net. So before that, F net was 0, right? F net was 0. So there's no resultant force. So it can be two cases, either not moving, okay, or moving with constant velocity. So which case is it? It has to be the first case, not moving, because they tell us that initially it was at rest. So I must look for the graph with the speed equals to 0. And unfortunately, all 4 options show that the speed was 0. Okay, never mind. Then we see that the next part, F net actually increases, right, to a certain value. And it became a constant F net. Okay, it became a constant F net. So whenever there's F net, there's going to be acceleration, right? Because F net equals to ma. Since the F net is constant and mass doesn't change, that means acceleration is going to be constant. That means I'm going to have constant acceleration. Okay, when it's constant acceleration, in a speed time graph, the gradient represents acceleration. So I must find a constant gradient graph, constant gradient. So all the 4 options, A has a constant gradient. This is gentle to steep, so the gradient is increasing. All right, this is, after that we have constant speed, that means 0, constant gradient. Sorry, not constant gradient. It is 0 gradient. It is flat. It is 0 gradient. That means it has no acceleration. Therefore, it has constant speed. For here is also 0 gradient. Okay, that means no acceleration. But I'm looking for the option with constant acceleration, which is actually our constant gradient. So this is our speed time graph, right? Okay, so roughly that was the questions that we have for dynamics. Not a lot, but it appears a lot more in the structured part. Okay, so now we will go and do DC circuit. So the first question comes from Anderson. Okay, so this is on page 5, question 18. Okay, so we have two resistors of resistance 30 and 60. They are arranged in parallel. So we have 30 and 60 here. The current in the 30 ohm resistor is 0.6. That means out of this V, I, and R, I already have I and R for the 30 ohm. Okay, so I can actually find my V equals IR, and I can find it for the 30 ohm resistor. It's equals to 0.60 multiplied by 30. So the answer will be 18 volts. Okay, and since they are arranged in parallel, that means the potential difference across these two resistors will be the same. Therefore, now I have the voltage for the 60 ohm. So V 60 ohm is equals to 18 volts because in parallel the potential difference is the same, right? So I use V equals IR. I substitute 18. I don't know what's the current in the 60 ohm. I know the resistor is 60, so I will then be 18 over 60. So the answer is 0.30 ampere. So answer is A. Okay. We'll go to the next question, which is in Bedok Green. Okay, question 18. Okay, so Bedok Green, page 30, question 18. They are asking at which point of the circuit is the current the smallest. Okay, A will definitely be the largest. Okay, because it is the current that is passing out from the main branch. Okay, so A current I of current of A is equal to current of D because this is the main branch. Okay, so now we are looking for the smallest. So if it is smallest, then current C is the smallest. So C is the answer. Because when the current comes over here, they will have to split. But when they split, they find that this is 2 ohm and 4 ohm. So therefore, the current in C will be the smaller one. Okay, will actually be the smallest because we have a larger resistance here. But we can actually do some calculation here. So let me redraw this circuit. Okay, so 2 ohm and 4 ohm. So maybe you can use this to also try to resolve this circuit. So the whole thing is 3 volts, right? And now we have 3 resistors. The 2 ohm and 4 ohm, they are in parallel and then in series with the 1 ohm. So I will have to work on this 2 resistors first. So 2 ohm and 4 ohm will then become 1.33 ohm. Okay, because I'll be using the 1 over IFF because I'm resolving for the 2 ohm and 4 ohm. So after that, the answer, if you work it out, will be 1.33 ohms. That means these 2 resistors that were in parallel can be written as 1.33. So I only change this. Okay, there's still a 1 ohm here. So now the effective resistance is for the whole thing, because now there are 2 resistors in series. Okay, so I can actually add them up and it becomes 4.33 ohms. Okay, 4.33 ohm. So now we will have a current that comes out from here, which is actually our IA. Okay, so how much is IA? We will have to use V equals IR. The V is 3, IA is unknown. The effective resistance is now 4.33 based on this circuit. Therefore, IA is equals to 3 over 4.33. Okay, and that will be equal to, IA will be 0.693 ampere. Okay, so now what I've gotten from the previous simple circuit is IA. So I can actually find what is the potential difference across these 2 resistors. Let me call it V1 and V2. Okay, so for V1, it is actually the current that passes through it, which is IA, which is 0.693 multiplied by its resistance of 1.33. So equals to 0.693 multiplied by 1.33. Okay. So I get something like 0.922 volts. How about V2? V2 will also have the same current of IA passing through it, multiplied by 1 ohm. So 0.693 multiplied by 1, and that will give me a value of 6.93. So okay, I realize I made a mistake because these 2 resistors in series is not equals to 4.33, it's actually equals to 2.33. So let me amend this. It becomes 2.33, and therefore my IA is 3 divided by 2.33. Therefore the answer is 1.29 ampere. Okay, 1.29 ampere. So now I have to redo everything here. The current here is no longer 0.693, it's 1.29. Therefore, V1 is actually 1.72 volts. Okay, V2 is 1.29 multiplied by 1, I'll get 1.29 volts. Okay, so how did I realize my mistake? Because you see, just now when V1 was 0.922 and V2 was 0.693, I add them up, it is not equal to this 3 volts. It's not equal to this 3 volts. That's where I realized, something must be wrong. But now if I add up 1.72 and 1.29, I will get 3.01. Then you may say, it's not exact 3 because we did a lot of 3SF round up just now. So, but the answer is still around 3. That means my calculation is correct. Okay, so if just now I have made all these mistakes, right, when you add them up, it will not be equal to the original 3 volts that is provided by the battery. Okay, so that means over here, we go back to the more complex circuit. Across this 1 ohm is actually 1.29 volts. 1.29 volts. Okay, and across here is actually 1.72 volts. How did I get 1.72 volts? Because it was from this 1.33 where I combine these two resistors in parallel together, and the potential difference across this 1.33 ohm is actually V1, and we actually managed to calculate V1, and I'm pretty sure my answer is correct. So V1 is 1.72 volts, and because these two resistors are in parallel, so their potential difference across them will be the same. I say again, because these two resistors are in parallel, the potential difference across these two resistors will be the same, which is 1.72 volts. So now I would like to calculate what is the current that passes through this this 2 ohm. Because I have the V, which is 1.72, I divided by the resistance, I will get 0.86 A. Okay, so how do I find the current that passes through the 4 ohm? I get 1.72 divided by 4. I will get 0.43 ampere. Okay, so I'm doing all this so that you know that the current in IC, which is the current through the 4 ohm, is the smallest, right? We started out with this, but over here all I did was to tell you that IA equals to ID because they both happens in the main branch. Then I talk about IA coming over to here and it split up, and because over here C actually has a larger resistor, so therefore a lesser current. Okay, and with the mathematics I managed to prove that the current through the 4 ohm is actually the smallest. Okay, now if you were to add them up, 0.86 plus 0.43, you'll get back 1.29 ampere, which is actually the current in the main branch. The current in the main branch, remember, is 1.29 ampere. Okay, so everything tallies. So you need to know when you're dealing with a parallel resistor, the voltage is the same. Okay, the current is sum. When they are dealing with series, the voltage is sum, the current is same. Okay. Okay, so the next question is from CHIJ. Okay, so CHIJ. Page 49, question 17. Page 49, question 17. So this is from CHIJ. they are asking for the smallest total resistance, and they give us values of 100 ohms. So sometimes they may not give you values, right? Then you can just put in any numbers. Okay, so as long as you follow the question, you can set them to be 20 ohm. That means every resistors have to be 20 ohm. So in this case, they're asking which circuit has the smallest total resistance. Okay, answer should be C. But let's do a calculation, because I know B, the total effective resistance is going to be 300 ohm, because they are all in series, right? So we just add up. So for A, if it's 100 ohm and 100 ohm and they are in parallel, this part will actually become 50 ohm. Okay, as long as we have two resistors of the same value and they're connected in parallel, I can just divide the answer, their resistance, by 2. So this one I'll get 150 ohm. Okay, so this one I'll get 1 over 100 plus 1 over 100 plus 1 over 100, and this will be equal to 1 over REFF. Okay, so I still need to flip it around. So REFF equals to 100 divided by 3. So I get 33.3. So far C has the smallest resistance. Then how about we check for D? So the top resistance has 200 ohm, the bottom one is 100 ohm, right? Because the top one, they are in series, so I can add them up. So it's 1 over 200 plus 1 over 100, so equals to REFF of D. So this times 2, so over 200, so 3. And I still need to flip this around, so it's equal to REFF is equal to 200 over 3, and this is definitely more than 33.3. Therefore, C is the answer. Okay, next question that we'll be going through is, okay, Greendale. So this is on page 68. All right. Question 17. Okay, question 17. So Greendale. Okay, now this is a little variation from what we did just now. Okay, so they, instead of giving us as 100 ohm, they tell us it's 6 ohm. But they also want us to find the difference between the smallest and the largest total resistance. So we have to do one more step. So from just now, the previous question, we know that this is going to be the largest. Okay, so you just add them up, will be 18 ohms. Then we know that this is going to be the smallest. Okay, but if, of course, this is based on what we have done just now and we were correct, but during exam, if you are not sure, please manually do some calculation. Okay, this one should be quite fast. So this is 6 ohm, 6 ohm, 6 ohm, so 1 over REFF is equal to 1 over 6 plus 1 over 6 plus 1 over 6, so and this is equals to 3 over 6. Therefore, REFF is actually equal to 6 over 3 equals to 2 ohm. Okay, so the largest resistance is actually 18 ohm. The smallest one is actually 2 ohm. So what's the difference between them? 18 minus 2 will give us 16 ohms. Okay, so the next question is from Holy Innocents. Hi. Question 16 and 17. This is actually on page 89. Page 89, I think. Okay, Holy Innocents. Question 16 and 17. Okay, so diagram 1 shows a resistor connected to a battery, an ammeter and voltmeter. So just to recap, ammeter must be connected in series. Okay, and this is plus, the long side is plus, the shorter side is minus, and voltmeter must be connected in parallel. Okay, so we see that the ammeter and voltmeter, they are both connected correctly. The ammeter reading is 0.5 ampere in diagram 1, so this is 0.5 ampere. That means a current of 0.5 ampere is coming out from the battery, and the voltmeter reading is 3 volts. Okay, that means this battery is actually 3 volts. That means the potential difference across this resistor is actually 3 volts. right? Because in parallel, right, voltmeter is connected in parallel, the potential difference is the same. Okay, so a second identical resistor is now connected. So with this, I can actually calculate what is the value of this resistor. Because the potential difference is 3 volts, the current is 0.5 ampere. So let me do a quick calculation. The voltmeter is 3, current is 0.5, so R is this, so R is actually 6 ohm. Okay, so this is 6 ohm. Right, now a second identical resistor is connected in parallel to the first one. Okay, so you'll find that once I have these two resistors connected in parallel, the effective resistance actually becomes 3 ohm. Okay, you can do a quick calculation there using the parallel resistors formula. So it becomes 3 ohm. So if it's 3 ohm, and remember my battery, there's no change, therefore the current will now be 1 ampere. Okay, and the potential difference is still 3 volts. So my ammeter reading is 1, voltmeter reading is this, so answer is A. Okay, so which of following is correct? The next question. Okay, I1 is equal to I2 plus I3. And in fact, this question, I think we have seen it somewhere in a previous question whereby I have 2 ohm and 4 ohm. So do you still remember, if I have a larger resistance, I will have a smaller current. Therefore, I2 will be smaller than I3 because here is a smaller resistance. Okay, but do take note that the I1 is equal to I2 plus I3. So let's look for the correct answer. So this is incorrect. I2 is greater than I3. This is incorrect. In fact, I2 is actually the smallest current. I3 is smaller than I1 and I2. Not true. I2 is smaller than I3 and okay, so actually D is the correct answer. Okay, so I think this is all for the MCQ in DC circuit. So for the PLMGS, I actually don't have the soft copy of it. So just look through all this, and then you can try and apply all this concept in your structured question. The next MCQ video that I'll be doing will be on electric charge and current of electricity.